The email I sent you? When I sent it? I've been here all day and I've been to 2 meetings so far. So I haven't gotten a chance to look at anything. I tried to talk to some persons via WhatsApp, but in terms of looking at the mails, I was in the doctoral meeting because I went to doctoral meeting.
Hi, Miss McCarthy.
Hi.
We're all here at the open campus.
Yes, I'm here.
We're all here at the
Okay.
open.
Did you guys remember that the class was at 3, right?
Yes.
You
Well,
see, the other students heard 3. You were the only ones who heard 3:30.
Some of us.
What were you saying, What were you saying, Jefffer?
Some of us heard. Some didn't know.
Some didn't know? Oh, no, I said it in class, right?
Yes, you did.
Okay. Come wandering Jews. Come wandering Jews. We're just starting now. Say it with first. All right. So do I have everybody now? I know that the St. Lucian students, they will be at their site. I saw Jeffer earlier. I'm not sure if the others are with her. Jeffer, are you there? Where are the others? Yay, y'all dressed up. Look at that. Right. But you're a bit low. Can you turn up a little bit more? Can you increase the volume?
Yes.
Good.
We have to bring it down for them.
All right. Okay, so my other students, I think I have students from Dominica, one from Dominica, and one from Bermuda. I'm not seeing you. Can you let me know if you're there? So my student from Dominica and from Bermuda. I'm not sure if I am reaching you. Can you see me? Can you let me know if you're connected? Nothing. Student from Bermuda. All right, so I think I'm going to start.
They're not there?
I'm not seeing them.
So you told us 3:34 you
I did not. Why the others heard 3?
They heard 3?
Yes.
So it's weren't much here.
I said 3. I could have said 3:30. I said an hour later.
Come here too.
Diane?
Yes.
Okay, so you're home and you're from Dominica or Bermuda? Bermuda? Diane?
Yes, I'm here.
Okay. You're from, so I'm
Dominica.
Dominica. So I'm waiting for my student.
Dominica.
Yes, from Bermuda. I know that's it because all the St. Lucian students are at one venue. So
Okay.
I'm fine with that. So I'm just waiting and I don't know if who is the person from, let me check my register.
Did you get my lesson plan? I sent it.
I'm just checking them now.
Okay.
I have my lesson plan in the car, my register in the car. I'm just checking through the lesson. I'm just gonna check my computer now for the lesson plans. So if I don't have it there, then I'll ask you to send it again, okay? So who am I missing? Am I missing Tasha? I'm seeing Tasha, I'm seeing Jeffer, I'm seeing, is it Sabina? I'm seeing Diane. What about Carlene? Oh, she explained something to me already. So who am I missing?
Then
Where is he? Zana.
might be late.
Oh, Zana is from St. Lucia, so she will be with you people?
Hopefully.
Okay, she was told, right?
Yes.
All right.
Yes.
All right, so we're not gonna wait on Zana. I'm just ensuring to have everybody. And so Dana wants to go first, so I will allow her to go first, and then whomever. So I need to get the lesson plan. I'll check my system.
I want to go. I'm not well.
You wanna go? Okay, so you'll go.
I'm a bit breathless. Yes.
All right, so right
So
up,
I have.
okay, so right after
Okay.
Dana, then you'll go. And then, so
Yeah,
Dana,
once you have my
I'll check my system for your lesson plan, okay?
I will do share screen.
Okay, no
I
problem.
can do share screen and I'll PowerPoint most of the points.
So if you do share screen, come, laptop, come.
Share screen, you should be able to, everybody who has a device should be able to see it.
Oh, so they need to get on the system too. She
Okay.
asked me she needs to show up PowerPoint and do some things. So she said that she'll do
I'm going on share screen. Everybody's going to
Here?
Yes.
Yeah.
So put them on the line.
Who's in the
I hate
This year, I know, the email.
No man, I want a tangible copy of it. It's just that the students oversee. Alright. What I'm going to ask you to do is this also. For each person, you're going to write down what went well and what area need any form of improvement. All right? Are we listening? So for each person, you're going to write down the good points, and then you're going to write down the points that are not so good. Okay?
We know this group right there about it. It might straight.
There's a projector remote.
Pio. I forget to make pencil. I forget to work out the thing. I forget to work them out.
What?
I forget to work it out. I'm putting in my PowerPoint. Now give me a pen. I'll have to scan it and put it in. Give me a pen. I'll scan it and put it in my
Yes,
okay. Thank you.
It shouldn't take too long.
Subtract. 51. You turn off the computer here? Okay.
Yeah.
To the back one, please.
Dominican of 4 cents.
47.
No, 4 cents.
Okay, that's good. Okay, fellow, all right.
I'm there.
What's negative 7? Negative 20 plus 2.
Minus
Negative
15.
Negative 15. Divided by 5. 10 minutes too long, man. The answer is 3. 5 into 15 or 2. That's verified.
Minus 3.
Minus 2. Okay.
The negative 15 divided by 5. Negative 3 divided by minus 3.
Diane, your mic is on.
Okay. Oops. Thanks.
Is there a All right. Good evening, everyone. Yeah, there's a black box. Hello, everyone. It's on you. Is somebody there?
Are you not?
Hello, everyone. Is that Jeffer?
Yes, we're here. Go ahead.
Did you guys receive my PowerPoint presentation? Because it's not showing clearly on the screen.
We didn't.
I emailed it.
Okay, well, we'll check now.
Okay. So you can just.
Yes, we got it. We got it.
You're seeing.
We got it.
You got it?
Yes.
Okay.
Yes.
So anyone else? Is on the same picture?
We're all here together.
Yes, they're all this. Okay, so I can start then. All right. Good evening, everyone. Now, I'm Dina Kerrigan. I'll be doing simple interest from consumer arithmetic. So let's get started. Now, press that down. They're watching. Yes. All right, everyone. Now
we're dealing with arithmetic consumers. So you know this deals with money, right? Now, say you have $1,000. I have $1,000 here, right? Would you like to borrow $1,000 from me? Anyone in class would like to borrow $1,000 from me?
No.
Okay. Now, do you think money is free to borrow? Diane? Jeffer?
No, it's not. There's nothing called free money.
Right. Money is not borrow. Now, how much does it cost to really borrow money?
Interest. The interest.
There's interest, exactly. So there's interest. So you know it varies, right? Now, interest is how much is paid. So you move to your second slide, and that's interest. That's how much is paid for you to actually use money. So you're being charged to use money, right? And this is actually as a percent or an amount. Now, to your third slide, you see there how interest is charged, right? As a percent of the amount borrowed, right? Now, there's a difference between interest and interest rate. Many times both terms are misused. Persons will say, oh, I got a 10% interest, and actually you got a 10% interest on that $1,000 to borrow it, right? Interest rate, right? But many times they're like 10% interest, but 10% interest, that would be like 10% interest rate. Percent, it's the interest rate. Now, 10% of $1,000, can somebody tell me that quickly? That's $100. No, $100, that's the interest. That is the interest. That's the amount. So on your fourth slide, you see where interest is the amount paid for the use of money, and interest rate is the amount paid for the use of money expressed as a percentage. So we have to be careful with how we use these terms. Now, moving to the fifth slide, you see there, Alex wants to borrow $1,000 from the bank, and he's given a 10% interest rate, right? So what's his interest amount? You worked that out a while ago. 10% of $1,000, that's $100, right? Now, it's very small. So you're on the sixth slide now, right?
Yes.
Where you see the keywords. You see that chart?
Yeah.
Basically labeling who Alex is, the bank is, the amount of money, that 1 year. And the keywords now, you have the borrower, you have the lender, which is the bank, the borrower being Alex, right? Now, for more than 1 year, Alex wants to borrow $1,000 for 2 years. And it's still 10%, right? What happens? What happens here? What if he wants to borrow for more than 2 years? Now, the bank is charging simple interest, so he's borrowing $1,000 for 2 years. The first year, the amount was $100 on that $1,000. The second year, it's going to be another $100, right? So that's basically $200, right? Now, how did you calculate the interest rate, the interest amount initially? For 1 year, you got $100. For 2 years, you got $200. You realize something?
10% of the initial amount borrowed.
Can you speak louder, please?
10% of the initial amount.
Right, and then for 2 years, you saw $200. So that means?
My bandwidth is low.
That's for 2 years. So now moving on to 5 years. You see, you got $100 for 1 year, $200 for 2 years. So that's multiplying by 1, that's 1 year. 2 years multiplied by 2. So if you borrow for 5 years, what's happening there?
You multiply by 5.
That's $500 there. So he's getting, because simple interest, what's key in simple interest is that you pay the same amount of interest every year or at the time interval that you're given, whether it's monthly or annually, weekly, but you pay the same amount of interest on the money that was borrowed. Now, in moving on, for the simple interest formula, how would you come up with a formula from that trend that you saw just now? Now, I title simple interest in I use acronym, simple interest SI, because initially, remember I was saying interest and interest rate, the amount is normally misused for the rate. So the amount that was borrowed multiplied by the interest rate multiplied by the year. That's how you got that first 1 year simple interest amount, right?
Yes.
And then the 2 years, you realize it was 200. So instead of that 100 from before, it went over it twice. So it's multiplied by 2. In 5 years, what happened? Multiplied by 5, right? Now, what happens here, there are terms in simple interest that they're key terms. So you have the amount that is borrowed, which is titled as the principal, and you have the rate. You have the interest rate, right? And that is titled as R, and you have the time, that's the time given for that loan, which is titled as T. Now for that simple interest rate formula, it's SI equal to P times R times T. Now it's written, it's on the presentation. I hope you're following. It's on that's the 9th slide. You're there?
Yes.
Right, because from you saw the previous trends, you're multiplying, it's the time, and given that you're paying the same amount of interest over the time period, all you're doing is multiplying by the amount of years, or if it was months or weeks, but we're dealing with years, right? Now, if you should do your multiplicative manipulations of this, you can actually find formulas for the time, the interest rate, and also the principal. But we're dealing here solely with the simple interest. We want to find out what's the concept behind simple interest and how we work around that, how we use that. Now, in moving on to the, everyone is clear?
Yes.
Wave.
Well, we're behind the camera, so. We're behind the camera, you won't see us.
Okay, right. Now, so you see you have your standard definitions, and it states, as I said, I repeated that, you know, it's simple interest is the amount of interest paid based solely on the original amount that you borrowed. It's based solely on that amount. Nothing is really adding up over time. It's based solely on what you borrowed initially from year 1. So you're paying that same amount of interest over the time period that you were given. Right? Now the principal is the initial amount of money you borrowed. What's the interest rate? That defines the percent of the principal that you're going to be charged for borrowing the principal. That's the initial amount of money. And the time, when the time is based on how long you chose. You chose to borrow $1,000 for 3 years. You chose to borrow it for 10 years, but you're paying back annually, so you know that's yearly simple interest. Or if you chose to pay back monthly, you know that will be how many months in 1 year? 12. So you're going to be paying every month 12 times, right? So if you say you borrowed for 2 years, but you're paying back monthly, that will be 12 months times 2. So that's 24. That's the time interval there. Now, let's move to the activity that you're seeing on slide 12. Everyone is seeing slide 12?
Yes. Yes.
All right. let's just focus on the first two questions there. Now, John borrowed $3,000 for 4 years at 5% interest rate per annum. How much interest is that? Now we're working with simple interest. How would you go about working this? What's the principal here? Right, and what's the rate?
1%.
And how would you state the rate in terms of decimals? I mean, are you going to be using the rate as a 5%, just 5 in your formula?
No.
Because you're actually using it as the 5%. What's 5%? How do you illustrate 5% mathematically in decimals, fractions?
5 over 100.
Right. So you have 5 over 100, and now for the time, what's the time interval? They gave her 4 years. And what was stated here? Per annum. They didn't say per month. Because if it was per month, you know that would be 4 years times basically 12. There are 12 months in 1 year. Right. Now when you multiply 3,000 by 4, the interest rate 0.05 here, what do you get? Anyone? Anybody mathing that out? What's the interest? That means the interest amount, the simple interest that John will be paying over the 4 years annually. It's 600, right. Now for the second question, I highlighted here because many times we tend to mix up the months with the years. Dan borrowed $2,000 for 6 months at 12% annual simple interest rate. How much interest is that? So what's the amount here? We know the principal, that's 2,000. The interest rate, 12%, and it's annual. However, you're given 6 months. How do you work that? That's half of a year, right?
Yeah, 0.5.
Exactly. So instead of multiplying by 1 year, that's multiplying by, for the time, that would be 0.5, right? Diane, that's what you just said?
Yes, 0.5.
Okay, right. Now when you calculate all of that using a formula, what do you get?
120.
120, exactly. So the interest amount that will be paid in 6 months will be $120 for the $2,000 that was borrowed initially, right? Now that's just the first activity there. Now, what's key in simple interest is understanding or being able to identify what the principal is. And what's the principal? That's the initial amount of money you borrowed, right?
Yeah.
Second, you need to identify the interest rate and be able to convert that into decimals, right? And then you have to also identify the time interval that you're given. Is it per annum, per month, per week? So those are key things. Now, how about the total amount that you're owing to the bank now? For that first question where we had John borrowing $3,000 for 4 years at 5% interest rate, and the interest amount was $600, how much would John be paying back to the bank? Basically, first of all, what did she borrow? How much did she borrow? $3,000, right. Now, how much would be the total that she paid to the bank after all this borrowing and this interest rate added? This interest amount, sorry, see, I'm mixing it up, misuse of the terms. What's the interest amount? For number one? So how much in total will be owed to the bank? How much does John have to pay back to the bank in total? 3,600. It's what she borrowed plus the interest. Now, the slide, I have a slide here. Now, this is just your final pop quiz bit, and I gave you steps 2 in finding the key. Well, not finding them. I just gave you a little instruction here. Now, if David borrowed $55,000 from a bank with a simple interest rate of 3% per annum for 10 years, how much will be the total owed to the bank after 10 years? Now, I would say group up, but since we have how many persons? We have St. Lucia, we have Diane, we have here in Mona. So I'm going to call in persons for the principal, to identify the principal, person to identify the time, the interest rate, and then find the simple interest amount, and then find the total amount that David would owe to the bank after 10 years. So who wants to tell me what the principal is here?
55,000.
Okay, so Ricardo is saying it's 55,000, agreed? Yes. Okay, now what's the simple interest rate? And you're calculating it now. So you want to that's 3%, but convert. How would you calculate in percentage? That's 0.03, and it's per annum, so no monthly multiplication here. 10 years, right, for the time?
Yes.
So when you substitute for the simple interest amount, how much is that?
16,516.
You got?
16,500.
16,500, right? So who wants to tell me now what will be the total amount owed to the bank after 10 years? Davy owes them how much now after 10 years?
71,500.
71,500. So after 10 years, this is what Davy has to pay back. Now, it's key to understand that in simple interest, what's happening is you pay the same amount based every year or at every time interval based on the initial amount that you borrowed. So if you borrowed $1,000, even if you borrowed it for 20 years, if it's simple interest rate that you're given, you're paying that same interest amount based on the principal, the initial amount that you borrowed. That's key with interest rate. And we also have to be careful with finding the time, identifying the time. Sometimes they're given 12 months and they're saying, oh, 12. You're given 6 months and you're saying, okay, the time is 6, but that's actually you saying 6 years. That's based on how it's charged. Annually, 6 months is not just 6. Annually, 6 months will be 6 out of 12 months. So that's half of a year, right? So these are key things that we need to be careful with as it regards to simple interest. Anybody learned anything new? So basic concept of simple interest, right? So I hope you enjoyed, and I'll take my $1,100 back because money is not free to borrow. Okay, bye guys.
You need the time. Yeah. Right, Diane, you're next.
Can't you all see it?
Okay, give me a second, please. I'm trying.
Okay.
My when I write scene. What are you writing? My
Should respond to her. I'm just getting her list back. Alright, I'm going to. Why am I not seeing her face? I don't know why the stick is coming to open.
Here?
I'm not
Or
seeing
you want
her.
her over here?
I want her here, please.
Are you hearing me though?
Wait a second, I'm still trying to prepare for my second time. I'm having some challenges. All right. All right, Diane, you may begin now. I'm just following your plan.
Are you seeing my PowerPoint?
I'm getting it up now.
Not the lesson plan, you know, the PowerPoint. I'm sharing screen with you.
EDMC
Dan, I think you're good to go now when you're ready.
Okay, good afternoon, everybody. And how are you? Okay, one sec. Okay. Today my lesson is solving two-step linear equations. And I want to congratulate the class. Your last assignment on substitution was very well done. So it's either you like P or you like algebra. So today we are going to start a new part of algebra, solving two-step linear equation. Yes, it's like the one step you did in grade 7. So just imagine, I asked Kenya to remove her shoe and socks and just take her foot out from underneath the desk. And I am going to put a sticker on her feet. on her foot. And Kenya, I want you to replace your socks. Don't look, replace your socks and shoe. Okay, girls and boys, what I put on the sticker is a monetary amount. And she can use it to buy recess, snacks for recess. What must she do to find out the value of her free meal? Can you respond? Obviously, she'll take out her shoes and socks and look. And she will look, and that gets us to where I want to show. Today we are going to solve the equations using something called flow diagram. So let's just think of the situation. The flow of information, unknown price. So what I did, she put on socks, put on shoes, potential free, oh sorry, my video. Okay. Sorry, I have to catch up with my, okay. So unknown price, she puts on socks, puts on shoe, potential free meal. Now, how would she get back to know what was the price that she won? So she will start, if she starts with the thinking about, boy, I have a potential free meal, she will take out her shoe, she takes out her socks, and on her feet, she will see the amount of money, and you can see how happy she will be. So today we are going to use the same process, analyzing, drawing a flow diagram to solve for the value of the unknown, and then we're going to verify the accuracy. So we have our first equation, and we want to solve for P in the equation 3P plus 5 is equal to 70. But before we solve, let us review the parts of an equation, and we are going to move from left to right. So the first thing we're going to see is the 3. Anybody can tell me what we call that first constant there, 3? What's the name?
The coefficient of relief.
Yes, thank you very much. The coefficient, and what does it tell us?
How many groups of P? 3.
Yes, how many groups of P? Very good. And P itself is called the
Variable.
Right. And what is a variable?
The one you're trying to find.
Oh, yes, it's the unknown. And
Amounts.
yes, but by the name variable. What else it tells us?
It varies.
Right, that is part of the expression that can take many values, right? Variable. And then we go on to our sign, our addition sign. What do we call that? Addition, subtraction, multiplication, division. Operations. Very good. Thank you. And what plus tells us?
Repeat the question.
The plus sign is an operation, yes. But what is the meaning of add or plus or whatever you want to call it? What does it mean? I'm not hearing. My class is asleep on me, man. What it means? That something has been increased?
Yes.
Oh, yes. Oh, that's it. And the 5?
It increased by 5.
Right, increased by 5, and 5 we call our constant. and the equal sign. How about that? What do we call an equal sign? It's an operator, yes. And what it means in this algebraic equation, what does it mean?
5 plus 5 must be 17.
Say it again, please. I'm not hearing you, Dina.
3
Repeat.
plus 5 must
Uh-huh.
be just the same as 17, the same amount as 17.
Yes, that I think I get the idea that your left-hand side is equal in value to what's on the right-hand side. So now we understand all parts of our equation. And in there's an invisible sign operation we didn't talk about. Where can I find that? If we look at the term 3p, there's an operation inside there. It's not written.
The multiplication sign.
Multiplication sign. It's really p plus p plus p. Remember that? Or 3 times p, right? So so the next step, so let's create a flow diagram of our equation. 3p plus 5 is equal to 17. So the basics, we have an input, we have our operations, then the output. So our input for this topic will be our variable. Then we have our operation boxes. Then we have our output, the given value, which is 17. So let's see how it works. So our flow diagram, the arrows will tell us how the information is flowing. So for the first flow diagram, we have P, our variable, our unknown. We don't know what P is. And we're going to take P, follow the arrow as they say. We're going to multiply it by 3 according to the equation, plus 5, and the outcome is 17. So we can find out, like our situation with Kenya, we can work backwards, or as we call inverse, and find out exactly what was P. So if we begin at 17 this time, follow the arrow, we are working backwards. And because we are working backwards, everything all our operations will be the inverse. So it will be 17. What's the inverse of plus 5? -5. Right. And after that, it goes to our next operation box. So 17 minus 5 is 12. Then we go to our next operation box. 12 divided by 3 is 4. So therefore, P is equal to 4. And that is our solution. To verify if P is equal to 4, we just go back to our last topic, substitution. We put it in the equation, and we know that it is true. We can do it this way, or we can go back to our first flow diagram. Don't know how to go back. And we can just put it in and follow the arrow, and we'll be sure it's 17. Anybody have questions now? Class, any questions? Anything not clear? Are you following the arrows?
Yes.
Okay. So it's your turn. So let's see. So you can talk among yourselves. You can ask me any questions. So we're going to work it together. Talk among your friends. Share ideas. And see if you can come up with your own flow diagram for the following 3 questions. 10 minutes is a bit long. I was over enthusiastic, but you should be able to do them in 5. Or would you prefer we do it together one by one?
through, we can fall and then.
I'm not seeing anybody. I'm hearing, but I'm not seeing anybody. I don't think you're seeing me. This is very odd.
I'm with you, Diane.
You're seeing me?
I'm not seeing you, but I'm with you.
Okay.
Diane, is your camera on?
Yes, it's on, but it seems that we cannot do the screen and the camera together. I have been trying it. That's why it took so long to move my PowerPoint, because I was there fiddling with it.
Okay.
But it just don't seem to be working. So, right. Anyway.
We can see the work though.
You can see the work. Okay, thank you. At least. So anybody wants to try the first one? Am I hustling you, class? Okay. So how about the first one? And please, I want you to describe what you're doing so that the whole class can hear you clearly.
Okay.
Give me a name. I'm not seeing anybody.
This is
Like, you know. I'm not seeing anybody. Anyway, go ahead there.
This is Gaffer.
Oh, Jeff. Yes. Jeff, go ahead there.
To balance the equation. To balance the equation, we need to subtract 3 on both sides.
No, we're not balancing. We're using our flow diagram.
We need to subtract 3 from 31. So we'll have 7x is equal to 31 minus 3.
Before you give me the second one, it's a flow chart, so you have to give me both of them. First, you have to break it down to show me that you understand what is the equation about. So, example, let me clarify. I will have x mapped onto, and my operation box will be times 7, right? Then my output plus 3, and my final solution will be 31. Answer or result will be 31. Then I'll be going in the opposite direction and starting with 31 and working my way back to x. Is it clearer now?
Yes.
Yeah.
Okay. So go ahead there. Go ahead.
Very clear.
Hello?
You're very clear, Diane. I'm following you perfectly.
Okay, go ahead, please. Who was answering?
I skipped a step, so I'm just putting it together.
All right, thank you. Anybody else? Come on, it's just drawing boxes. It's supposed to be the easy one.
Opposite operation.
Yes, we do it opposite. We're getting accustomed to 2 things. First, that we start with the non-variable, the term with the non-variable term. And secondly, it's about doing the inverse. So we are getting ready. We're getting ready.
You want number 2? Yes. You want number 2 now?
Yes, question 2. Anybody?
I'll try. Okay. So
Okay, go ahead.
we start from the right hand side and we go. Okay, so we have negative 17, and then we have a negative 2, so we'll do the opposite of that. We'll add 2.
Yes.
So we'll get negative 15.
Mm-hmm.
And then we have 5x, which is 5 times x, so we're going to divide by 5.
Yes.
Divided by 5 to get negative 3.
Very good. And have you verified your answer?
Have I verified my answer?
Yes. Go ahead, verify your answer for me. Justify the answer.
5 times negative 3 is negative 15.
Uh-huh.
And from that, you'll get negative 17, which is the same.
Very good. Very good. I'm impressed. I'm impressed. And anybody wants to tackle the last one? Don't everybody rush, please. Come on, it's just grade 8. Oh, how terrifying could it be? Let's go. T is mapped on to times 5/8 to map on to +3, and our result was 13. How do we work our way back? I'm not hearing him, Mr. Body very soft.
Starting from 30. Right?
Ricardo is doing that for you, Diane.
Okay, thank you. Go ahead, sir.
So the +3 would be -3 or negative.
Uh-huh.
And you take that away from 30.
Yes.
10.
10.
Yes. Okay, you have a fraction there, 5/8 to 5/8t.
Mm-hmm.
Divide 5/8 by 10.
Uh-huh. 10 divided by 5/8. Uh-huh. Go ahead.
You would say flip.
Mm-hmm.
You multiply by inverse. 5/8 becomes 8/5.
Okay.
Which is 8/5.
Mm-hmm.
Which is 16. Therefore, equals 16.
So therefore, T is equal to? T is equal to?
1/6.
0.6.
No, 16.
Oh, 16. Thank you. Very good. 16. And did you verify your answer?
5/8
Mm-hmm.
plus 3 equals 30.
Okay. You all did excellent today. So I want 3 students. So excellent today. So let's just go over some of the main points we did today. First, we did the different parts of the equation. I think everybody got that nice done. We understood that an equation, the equal sign means left and right. And by working backwards, our skill today was working backwards, we can find the unknown. So we're moving from the known right back to the unknown. So time is up. We're almost 5 minutes before the bell. So this is what we're going to do. Next week, Tuesday, I want on pad sheets to be handed in for our answers. Okay, there it is. Do numbers 1, 7, and 10, page 71, exercise 7 from your textbook. I will collect them personally in the morning after assembly. And so in closing today, our next class is next week, Tuesday, and we are going to the audiovisual room. We have 2 other ways of solving equations, and I have a video on using tiles just to show you. So please be ready with your books to move immediately to the audiovisual room. Time to pack up. I hear the bell. Good day, ladies. Good day, gentlemen.
Thank you, darling.
Okay.
Who wants to go next?
Anya wants to go next.
All right, Jeff, I see you.
Okay, let me close my screen. Stop sharing.
Anya wants to go next. Okay, Anya.
And then,
Okay, so this is.
Your
voice good, Jeffer. Okay, Anya.
I'm just putting my PowerPoint up. Oh, okay. Because it has a video sound for everything. I have to change it in the PowerPoint to do that.
We have taken on the jump drive.
Yeah.
Miss Nicole help to put up the
Yeah, just give me 1 minute.
All right. All right. In the meantime, I'm just gonna run for a second. Give me a second. I'm still asking for another second.
Are we ready now?
No, Miss is not here. Give her a minute. Miss McCarthy stepped out. And because the courses are so, they are crash courses. It's too big. All right, I'm ready now, Anya, when you are.
Hi, we wanted to verify something. Can all of us go today because we only get this place today? Otherwise, we have to go back home. So we were asking if it's possible for all of us to present today. All the solutions.
Yes, I'll allow you guys to go first. Is that okay with everybody else? Definitely, so I'll allow you guys to go first, okay?
Thank you. Okay. All right, hello everyone.
Hello. Hi, Anya.
Hi, Anya.
Just now. Okay, I'm going to play a short video for you right now. So I really need you all to listen. Listen to what the guy is saying. And then we will start with the
Hello, and welcome to a video presentation on congruent figures. Here's what you'll learn: how to identify congruent figures and use congruence to solve problems. Congruent figures have the same size and shape. Look at the center circles below. Which one is larger? Most people believe the one on the right looks larger, but it's an optical illusion. They're both exactly the same size, and I can prove it to you. I'll draw a blue circle on top of the center circle at left and slide it over to the one on the right. They match exactly, so they're both the same size. The two center circles are said to be congruent. Now identify congruent shapes in this image of a backgammon game. See if you come up with the same congruent figures that I do. It looks to me like the playing pieces are congruent. Also, the dice appear to be congruent. The triangular space, like the storage areas around the outside edges, are also congruent. Now, the pieces we just identified are congruent, even though the colors or markings may not be the same. But remember, for congruence, we're concerned with size and shape, not any colorings or markings on the figures. Now identify congruent shapes in this image of a target. Well, there are a lot of circles in the figure, but the circles are all different sizes. So that means there are no congruent figures in the target.
Okay, so from the introduction, you should know that my class is about congruent figures, but we're going to look at triangles in particular. Now I have two pairs of triangles. The first pair, they are congruent, but the next pair is not. Now, can anybody tell me why the second pair is not congruent and why the first pair is? Anyone?
Me, miss me.
Yes,
The size, the length of the sides are the same, and for the first one, and the angles are the same.
Very good, Diane. Can someone else tell me for the second one why they are not congruent?
Me.
Yes, Geffer.
The length of the sides are not the same.
Right. So Geffer just said that the lengths of the side are the same, but what else do you notice? However, the angles are the same. All right. Everyone with me? Mona? Hello?
Yes, we are with you.
Okay. All right, so just to review that congruent triangles, they're the same shape, of course. They have the same three lengths. They have the same three angles, and corresponding lengths and angles are equal. So look at the two triangles, ABC and MLN. Do you all recall what those straight lines mean? Those straight lines, the red lines, what do they mean? I have one stroke on AB and one stroke on LM. What does that mean for AB and LM? They're equal lengths. And if you have two strokes on AC and MN, that means they're equal lengths, but they're not equal with AB, neither BC, right? Right. And the same thing applies for the angles. Angle A is the same as which angle? Angle M. Very good. So you notice that since LM is equal to MN and AC is equal to, since LM is equal to AB and AC is equal to MN, then A and M must be equal for it to be congruent. Okay, miss. Okay, so let's look at this situation. There is a sailing race taking place. One rule of the competition is that all sails must be the same size. Assuming that all sails are triangular in shape, how can the director ensure that the sails are the same size? Anybody wants to try? Just one person? What do you think? Anyone? Someone in Mona? Hello?
Dino?
Somebody in Mona?
No one in Mona? Are we sleeping in Mona?
No, they're thinking.
Mona, wake up, Mona.
Can you think of any way? If you can, that's okay. We'll get back to it later in the lesson. Okay, then we move along. All right, now I want you all to take your Dean's blocks, the 10s. You should have that with you all. Take 3 of them out. Now in my picture, I just colored them for simplification since I wasn't depending on technology. Everybody have them?
Yes, miss.
Thank you, Zana. What I want you all to do is take one side, cover with 6 units, the other side 7 units, and the other one 8 units, sorry, and we're going to combine them together to form a triangle, as you see in the picture there. Again, you don't have to color it, I just colored it to emphasize the lengths you need. The red is 8, the blue is 7, and the green is 6. It doesn't matter the orientation. So I'll give you all a few seconds, about a minute to get that done.
Miss, you do that already.
And get out your protractor. Go into pairs to do this for me, please. I know, Diane, you don't have a pair, but bear with me. One side is 8, one side is 6 units, and the other side must be 7 units. And join them together to form a triangle. You can tape them down or anything. Have one person using their fingers to keep them down. Because you need to measure the angles with a protractor. The 3 angles.
Very good.
Very good. Okay, those in St. Lucia, they've done it. What about Diane? You progressing okay, Diane?
Yes, all 3 of us, I, me, and myself.
That's good, Diane. So you have 3 people, not pairs. What about Mona?
Still working?
Still working? Okay.
One like 6, 7, 8.
6, 7, and 8.
6, 7, 8, 8. This will be.
Give us a minute, Anya.
Yes?
They're still working. Give them a minute.
Sure, no problem.
And so you have a protractor from a triangle. Please put them in.
Any angles in order? Any angles?
Okay, they're measuring. What's it coming up with there now?
But I'm measuring from what's up because that just slip on.
They're still measuring, still working.
6, 0.
Yeah, 48. Are you want to give me the answer that you're coming up with?
Is there a 48 angle or some like between 45 and
48.
48?
And then we got one of the angles similar. They got 47, right?
Yeah, between 48 and 50 thereabouts.
Yes.
That's between the blue and the red.
Yes.
And there is 75.
Very good. Yes, 75.
So that's 75
student.
So that's 75 and 48. 75.
Okay, so let's say those three angles together again.
So that's 75, 48, right? And so the next one, that will be 57.
Okay, but here we got 58, 75, and 47, which is approximately the same. Diane, what about you?
One of mine's close. One is 58, one in the corner. Other than that, I don't know. I can't keep my bricks together.
Yes, because yourself and I not cooperating, I understand, Diane. Okay, so all of us, we got the triangles to have very similar, or we could say the same angles. Of course, there would be error in measuring. So what do we notice? If we have, we answered the sizes, nobody measured anything that was too different. And are those triangles, would they be considered congruent? What do you think?
Ignoring the errors.
Ignoring the errors, yes, very good, Gaffer. They would be congruent. And what can you conclude from this activity about congruent triangles? Like, what do we need for us to get congruent triangles? Right, so if you know three sides, then obviously the triangles need, if the three sides are equal, they are congruent. Very good. And this is called the side-side rule. And we usually shorten it as SSS. Now, if we remove one of those Dean's blocks, I chose in my diagram to move the 8th one, we will notice that nothing else can fit there to form the triangle. Now, I was going to make it interactive, but with time, we have to fill it up a bit, okay? So do you understand what I'm saying? If I took out the 8th one, the red one, for me to complete the triangle, there's no other length I can place there. Do you all agree? So therefore, what do you think this means? That if, anybody? In other words, if I took out the length, that 8 units, what am I left with? Two sides, and the angle in between the two sides. Everybody sees that?
Yes.
So if you have two figures where the two sides and the angle in between them are equal, then we can assume that the third side will be equal and the two triangles are congruent. Everybody understands?
Yes, good job.
Okay, so I'm going to skip this slide again with the time, but we have to be careful about something. It must be the two sides and the angle in between, because if we know two sides are equal and any other angle, then the triangles are not necessarily congruent. Everybody understands? Okay. Now we had a third activity with the tangram pieces, but well, we don't have much time left, but I will just go through it with y'all, okay, so we could understand what's going on. If you look at the picture on my PowerPoint,
okay,
those two pieces, they look familiar, right?
Okay, Anya, I'm gonna give you some advice. That time is just 1 mark. You can pick up, if you finish these activities, you can pick up 4 marks. So you decide.
Say again?
I'm saying that if you're measuring the time that you have, I'm gonna give about a minute that I'm used to talking. If you measure the time that you have, be careful in how you choose to teach the concept rather than focus on the time, because the time is only 1 mark. And okay.
Okay, thanks. Well, get out a ruler. And on a piece of paper, draw a line 20 centimeters long. So you have a ruler, supposed to be part of your kits, and you draw a line 20 centimeters long. Take out the small triangle in your diagram pieces and the square, and place it as how the diagram is showing on your 20 centimeter line. Use the bottom of your paper because you will be going up. So for example, you're using your paper in landscape and use the bottom of your paper. The small triangle and the square. You've placed the longer side of the triangle on the line you just drew. And you place the square on the other end of, you place on the other end of the line. Okay? And then you see the two green lines, you're going to extend them to complete a triangle. So in other words, now you have one side and two angles, in other words, and you're going to complete the triangle with that information. Diane, are you okay?
Yes, I'm all right.
Is Mona doing okay?
Yes, they're working.
Okay, thanks. Okay. Do we have any length so far?
It's not fitting on their page.
Oh, shucks. Should have used the extremes. Use the extremes. You see, look, it's 45 degrees. So in St. Lucia, they found 19 and 28. Did anybody get anything way different?
Okay. Yes, I have like 20 and 28.
Something completely different than close to it? Una?
Close, they have something close?
I have 28 and a half and 20.
28 and a half.
Okay, that's close. Of course, with error, we'll find very slight variations. But it shouldn't be way off, like somebody with 10 and somebody with 40 centimeters. Okay? So if everybody is getting the same triangle, okay, well, they remeasured and got 29. Yeah, Mona got 28.5, so it's the same. It's very similar. The other group got 29. Okay.
29, but I actually measured it on your on the on what you projected with my ruler and kind of the length 20 on my ruler is 6.5 because the page was my page is too short for the drawing. So I use my ruler to do the manipulation right there.
Oh.
29 is currently hypotenuse?
Yes.
Okay.
Okay, so I want someone from Mona to tell me what rule are we demonstrating here, to give in their own words, tell me what rule are we demonstrating here for congruent triangles. Because I haven't heard input from them. Anyone?
The side rule.
Then the side. But what about that one? What do you think is the rule for the to know if two triangles are congruent?
Oh, if you have two same angles.
Okay,
if you have two angles and one line. Then your triangles will be congruent.
Very good. And that's the third rule, that if you have two angles and one side, it doesn't matter which two angles, it doesn't matter which side, then for sure they will be congruent. And as the two things demonstrate. So you have angle, side, angle, or angle, angle, side. All right? Everybody with me?
Yes.
Now let's go back to our dilemma with our director and his sailing race. So, what do you think would be the most efficient way for him to check if the sails are the same? Yes, Sabrina, what should he do? One way?
Measure the length of the sides or measure the angle.
She said to measure the length of all the sides, which is the first rule we learned. So that's side. Very good, Sabrina. Anybody else? How many angles? How many sides? You have to give numbers. Does he have to do all? If he does, and the angle in between. Very good. So if he measures probably the height and the base, and then the angle in between would be what? Would he have to measure that? It would be a right angle, right? So all he had to do was measure the height and the base. Anybody can think of a third one?
You can go, you can have one side, the hypotenuse on the right angle.
Very good. So that is which rule, Diane?
I just said it, I don't know, it has some RHS or something, I can't remember.
Yeah, but you said two sides and no, you said two angles, sorry, and one side, yes.
Yes.
Very good, Diane.
AFA.
Very good, yes. Okay, so these are the answers. So measure two angles and the height of the sail, measure the lengths of all three sides of the sails, or measure the height and base of the sails and the angles in between. Okay, so here's an exercise for y'all to do. Now I'm going to give you a minute for y'all to tell me whether the first pair is congruent, the second pair, if it's congruent, why, the third pair, if it's congruent as well. So we have three pairs of triangles. Y'all could discuss amongst yourselves because you have to give reasons. Okay, anybody ready with answers? What about number one? That goes to Mona.
They're not congruent.
Very good. They're not congruent. Why?
Location of the angle.
The location of the angle. Excellent. Okay, number two goes to Diane.
No. we don't know the length of the, well, they share the same, it is, because they share the same size.
They are congruent, yes, Diane. Why?
So the three sides are the same length.
Very good.
So therefore they are congruent.
Excellent. And the last one comes here to St. Lucia, yes?
Yes, they are.
Yes, they are, yes, but why?
The two angles. The corresponding angles are equal.
Yes, and the line, there's one line that's the same length because they're sharing one line, right? So it's the same length. Okay, and for those who probably missed the answers, they are re-emphasized here. Okay, now thank you very much for participating and listening to this lesson. What I want you all to do, those in Mona and Diane, if you have a chance, you could WhatsApp what you have learned today. And if there is anything you understand, because I need to get some feedback from for the lesson, and right here in St. Lucia, they will just, we understood that? So you could just WhatsApp in the group. Okay, so thank you guys for participating. And I now leave you for the next presenter. Thank you, Diane. Thank you, Mona. Thank you, St. Lucia.
You're welcome.
All right, who wants to go next? Good job, Anya.
Sabina is coming.
Sabina is coming.
Sabina, you're going next?
Yes, so just a minute for.
Anya, right?
Please ensure that you take your notes. Could you start for me, Sabina? We're ready. I don't want to save all the lessons for tomorrow because there are other things that we want to look at. No. We can meet next week. So we're going to be here next week. The course is end tomorrow. I'm not coming here next week. No, I mean, you stop the teaching. Like, yeah. And I have actual kids.
Okay, are you ready?
Is everybody
ready?
Yes, finance is all assignments right, should be in. And not drop off at office. But just email it to me because yeah, I'll just there to If what? you know, you see, I'm being kind because
Yes, I'm ready.
Okay.
Okay, good afternoon, everyone.
Good afternoon.
For my introductory activity, okay, before I start, everybody will not be able to participate in all of my activities because I did not send them beforehand so that they could be printed. So I have many activities here, and I will let you know what they are and try to put them on the screen, but the students in St. Lucia will participate, and everything that you can participate in on the other side, hopefully. I'll try to put it on the screen. Is everybody hearing me?
Yes.
Okay, for the introductory activity, we have a puzzle, a Sudoku puzzle. So I am going to give you 2 minutes. I'll try to put the whole thing on the screen. 2 minutes so you could see how many you can get filled in. It says write the number from 1 to 6 in each square so that every row, column, and mini grid contains the number from 1 to 6. 2 minutes, the person who gets the most will get $1,000.
Yes.
Monopoly money.
You know, sharing screen.
Where is it? Where is it? Where's my...
1 second.
Oh, okay, okay.
Can you see it now?
Can you see it now?
All of them?
No, you try to do as many as you can. 2 minutes.
Okay, so if I should participate, no, I need my money.
Yes, you get your money.
Transfer, wire transfer.
Monopoly money.
If you change, I know for sure.
Oh, sorry. I want to do my money. Timing.
5.
That's for grade 9, remember. You finished? Okay. You want to do as many as you can? Maybe 30 more seconds.
Should we do both of them? Do all of the all 4?
Okay. You were supposed to try to do as many as you could in the 2 minutes. So your time is up. Your time is up. Let's go. How many persons did all 4? Nobody completed? Okay, no, the person who gets the highest, it doesn't matter. If anybody finishes one, then that means you get $1,000. How many persons got 3? Anybody in Jamaica got 3?
No, we could only see 2 puzzles completely.
Mm.
The other bottom ones, the bottom part of the top.
This is the solution. You can look at what you have. Did anybody complete 3? 2? Gefa, look at the solution. Gefa said she finished 2. The first 2.
I want
Okay. But how many persons were able to finish the first one? At least the first one.
The first one, there's the
Okay, I think we have a winner in St. Lucia. Gefa won, so she's going to get, yes, she's finished with 3. So this is her $1,000.
What is that?
So the $1,000 goes to Gefa. Okay. For the next activity, is everybody ready?
Yeah.
We're going to move on. Not yet. How do I do that? I have to get out. Sing me another one.
Come on. Let's use it.
Show myself, not this screen. Okay, so I'm continuing. For the next activity, today I'm going to give you a special offer. Everyone in the class. Now, I'm going to offer you 2 options. You have a choice. You can receive a check from me for $1 million. I guarantee you, if you go to the bank, you can cash it and you will get your $1 million. Or you can agree to take 1 penny today from me, and I will double whatever you have in your account every day for the next 30 days. So I want each person to make a choice. Option A, a check for $1 million today. Option B, receive 1 penny today, and each day for the next 30 days, I will double the amount that you had in your account the previous day. So everybody make their choice. Now I don't have the check. Well, I didn't send the check to Mona, but you can make your choice and you let me know. So you make a choice, $1 million, I'll give you a check. In St. Lucia, $1 million or penny.
I'll take the million.
Okay. We have Gefa, Anya, and are taking $1 million check.
That better be a real check.
The check. Okay.
Yeah, she's like, no.
Diane, what's your choice? The $1 million check or the penny a day? The penny, which I will be doubling every day for 30 days.
What is your solution, Penny? 1 cent or 2 cents?
1 cent.
We have the same currency.
We have the same currency. 1 cent.
You have the 1 cent and 2 cents.
They just took it out of the market. The same situation there, but we still have them.
We have the 1 cent and 2 cents again.
Now.
So I will take the check. We have no 1 cent and 2 cents.
Okay, take your check. In Jamaica, what are your choices? The 1 cent?
The million.
For the next 30 days? Or the check?
The $1 million.
Okay, so we have $1 million check.
You want to know what it says?
Nobody has taken the penny option. Okay. Is anybody taking the penny option?
Penny option.
Okay, Dana, is that Dana?
Yes, it's Dana and David.
And David.
David, okay. So Dana and David are taking the penny option. Very good. Okay. Those who chose option B. Should have written it. Those who chose option B. I wanted to show you my board, but I'm just going to tell you how your money is going to grow. I will show you a chart in a while, but I don't want to show it right now. Let me see if you can see the whiteboard. It's probably too far. No, you can. Okay.
Can you all see the board?
Yes, we can.
Okay, day 1.
Yes, we can see.
Okay. So we have the value. So you have this and value. Day 1, that's the value of your money. Day 2, it will be 2 cents. Day 3, 4 cents. Continue. I'm just going to write the arrow. Day 10, $5.12. Day 20, you know there's a gap. Day 20, the value of your money will be $5,242.88. Does anybody want to change their mind now to choose the penny? Everybody's satisfied with their choice. Nobody's changing to the penny.
Yes.
Okay, I want to share something with you. Just bear with me for a second. I need to open it. Shucks folder. Am I sharing my screen? Is everybody seeing? Are you all seeing what's on the screen? Okay, just hold a second. Give a hear me. Okay, so day 20, this is the value. Nobody wants to change their mind. I just want you to see from day 20 onwards. Do you see how much it is?
Yes.
In 30 days, do you see how much it is? In 30 days, 1 penny double its value every day to be $5,368,709.12. 2 persons made the right choice. Dana and who was it? Dana and Davy. So Dana and Davy will get 5 times as much money as those who took the $1 million check. Okay. Why do you think this happened? How is that possible? Can anybody tell me how is that possible?
It depends on what you have before and not what you had initially. It depends on the amount you make all the time instead of what you first started with.
Or the way they calculate the interest.
Yeah.
Okay. Well, you have to say so that they can hear the answer.
Oh.
Does anybody want to share?
It depends on the way the interest was calculated.
Okay.
Unlike the first class, where it was
Simple interest, it would provide the same amount all the time.
That one grows according to how much, based on the interest before.
Accumulated, what was the accumulated?
Are you all hearing the response?
No, not clearly.
In the class before, we were looking at simple interest where money grows at a constant rate. So the person will receive the same amount each year as interest. But in this case, the interest is calculated differently. So therefore, the money, it's based on how the money is accumulated and a percentage of that.
Okay. I don't know if you heard what she was saying, but it said she was trying to use Dana's class where she did simple interest and said that it depends on how the interest is calculated. The secret basically to it is compound interest. This is my topic. Compound interest. The interest is not just calculated on the original amount, which was 1 cent, but it's calculated based on what's in the balance in the account at the period of time. So it's the original amount plus the interest. In this case, the interest was 100. The rate of interest, we learned all of that from Dana. The rate of interest was 100%. So every day you get twice as much as you had the day before. So we were compounding, you're adding interest upon interest. Okay, so compound interest is defined as interest calculated on both the principal and the accrued interest. So both the principal and the interest from previous period will be receiving interest. With simple interest, the interest is only calculated on the principal. So if you started with the 1 cent, every period of time, like every day, the interest will only be charged on the 1 cent. But with compound interest, the amount is charged on the amount. The interest is charged on the amount that is in the balance in the account at the time when the interest is being given. Okay.
On the top, this is top sharing.
Okay, so we're moving on to the activity. Does anybody have any question so far? Okay, I want to show you how a compound interest is calculated. We're going to use a real life example. Compound interests are used by financial institutions. When you save your money when you put your money in a bank, the bank uses your money to give loans. So they pay you interest for using your money. And if you take a loan from a financial institution like a bank, you will pay them interest for the use of that money, for the use of their money. So normally they do not use simple interest, but compound interest is used during those type of transactions. It is also used by companies when you're taking out loans or hire purchase. Okay. Like COTS, but I think they have COTS in Jamaica also. Okay, so is everybody hearing me? I'm not sure if you're still there. Okay, everybody's so quiet. I'm not since I cannot see, I'm not really sure. Okay, so for the next activity, what I want students to do is to calculate the value in their account using compound interest. So we're going to use a scenario I did not write it to put on the board. No, I could write it down. We're going to use we're going to use a bank setting to do this activity. Now the students here will have their cash box. It has money in it. I'm sorry, you don't have it in the other sides. You have $50 bill, dollars, cents, and coins. So they work in groups, and you can do that. Work in groups, at least 2 persons per group. One person will be the banker, and one person will be the depositor. So the scenario is your grandfather. Remember, this is grade 9. Your grandfather was here. He visited for Christmas. He gave you $1,000. You decide you're going to put it into a bank account. One time deposit to the bank account. The bank is paying 5% compounded annually. So you deposit this into the bank. The bank is paying 5% compounded annually. You're going to leave it there for 3 years until you graduate. Then you're going to use that for graduation and ball. So one person is going to be the banker, and one person is going to be the person who received the $1,000 from the grandfather. So you have the $1,000 check and deposit it into the bank. And what I want you to do is to use the monies that you have to show me how compound interest is accumulated. How much money, or basically you need to be able to find out how much money will you have in your account at the end of the 3rd year. I don't want you to actually, well, you can use your calculator, but I want you to actually use the money to be able to tell me how much. 5% interest. I'm going to write that down. You got $1,000 for Christmas. You deposit it to an account. One-time deposit. It is left there for 3 years at 5% interest. I'm looking for math. Okay, you'll find out how much interest you get each year. You're familiar with simple interest. We have done simple interest. You have done simple interest. So you should be able to calculate how much interest that you have each year.
You want the total afterwards? You want the total amount afterwards, or you want the interest yearly?
I want interest each period and the total in the account.
First period, is it 150?
Hold a second, just give the, what was that?
Is for the first period, is that 150?
Oh, you're giving me the answer already. I was going to give them some time to work. $5% interest.
You compound them, no?
For the first year,
For
you
the
get
first year, you
$50.
get $50. The second, 50.
The second, you get $52.50.
And the
Okay, just hold a second.
it's compounded.
Let me try to. I'm going to get off the screen so I can put some things on. Let me take this out. Am I still sharing my screen? Anya, please come and help again. No, not yet. I will not share the screen so that I can put out the others. I'm not sure. Stop here. I want to take out these things just now. I want to close out. I want to open these ones so I can have them at the bottom. Just now. No, I'm not sharing right now. I'm just downloading some of these things. Okay. One minute, my precious things.
It's different. It's one.
Okay, let's go over what you got for your answer. And as we go through it, you can complete the worksheet. Well, the students here have it, just fill it in. You can complete this worksheet. I'm going to put it on the screen. So, can you see the worksheet on the screen? Am I? No, they're probably not hearing me. I'm not sure if I'm seeing it.
We can see you. We're seeing it on now.
Okay, you can hear me?
Yes, we're hearing you.
Okay. So in 2015, which is when you got the money in 2014, Christmas 2015, it was deposited. At the end of 2015, %5 interest. So for the first year, it was, well, we had somebody who said $50, and you could, it's written right there. So for the balance at the end of the first year is $50. So we need to continue the rest. For the second year, 2016, the beginning balance, $1,050. Does everybody agree?
Yeah.
The interest remains the same, 5%, or $1,050. So the second year, Diane, what's the interest earned? Second year. What did you get for the amount of interest earned? Anybody in Jamaica wants to answer? Interest earned the second year? In 2016? $52.50. So therefore, very good. The ending balance is $1,102.50. So what has happened there? between the first and second year, interest. It moved from $50 to $52.50. Okay, it has increased, as they said. It means the $1,000 still got the $50 interest, and the $50 from 2015 got 5% interest, which came to $2.50. So you have the principal had an interest of $50, and the interest also received interest. The third year, 2007, the beginning balance will now be 2017, sorry.
$1,102.50.
$1,102.50. And this amount will receive interest. 5%. So what was the interest 2017? $55.13. So when you add that, the ending balance will be 1,000. What's the answer?
$1,157.63.
Okay, $1,150. $57.63. So that's for the third year. That's for the third year. I'm going to just show you for the next 5 years. This is what it will be. So that's what you should have. The completed worksheet will look like this.
1,000.
Is everybody seeing? Okay, the completed worksheet, we have for compound interest for 5 years. What do you observe?
Can you repeat that, please?
We have the completed worksheet on for the 5 years for compound interest. There's simple interest there, but I don't want you to answer about this one. Is it just what do you observe from the calculation, the compound interest figures for the 5 years? What has been happening?
Every year is different.
What is different every year?
It's increasing interest. The amount of interest received is is different.
Okay, Daniel said the amount of interest earned is different every year. What else can you observe?
So the initial amount of money that was in that you had, like, you know, for instance, you had the principal, so each year the principal is going up. It's compounding. It's principal.
The principal remains the same, but the ending balance and the beginning balance will be different.
Yeah.
But the original principal will always be $1,000.
Present value and future value. So each year the future value is going up. Like the future value, you're having increased future value.
Okay, you're in grade 9, you don't know about future values yet.
The interest the amount that the interest will be accrued on changes every year.
The amount that the interest is charged on right increases it changes every year. So in 2015 it was on the $1,000, in 2016 $1,050, 2017 $1,120, etc. So it's the original principal plus the interest from the previous period. So the principal still maintains its $50 interest, but the interest also receives interest. So that's what we refer to as compounding. Okay, so to calculate the total, you are supposed to answer 2 questions. To calculate the total interest that you receive, you can do that in 2 ways. Can anybody tell me one way you could calculate the interest, total interest received over the 5-year period? You'd have had the table.
So just add the sum of and the interest.
Okay, one person said add the interest earned, which is the 4th column.
Yeah, the sum of the 4th column.
The sum of the 4th column. You'd add everything together, 50, 52, 50, 55, 5788, and 6078. That's one option. What's the next option?
Find out how much interest in you can take the final, the balance in the last year and subtract the $276.29.
Okay, if you add all of them together in the interest earned column, you'll get $276.29. Or as Geffer said, your original principal is $1,000. That's what you had before, your original amount. The balance at the end of 5 years is $1,276.29. So the difference is interest, and that will be your compound interest. Okay, if you look at the two of them, the simple interest and the compound interest figure, simple interest and compound interest table. I'm trying to show both of them for the 5 years. I just want you to spend a few seconds and look at it and tell me what you observe. For the same figures we have calculated, the first one is compound interest, and the second one is simple interest.
You have to wrap up your lesson now. You've been going on for a while. You have to wrap up now. That's 35 minutes. Double the time. You have to wrap up your lesson now.
Okay. I want somebody to make an observation between the two, simple interest and compound interest.
It's just the same amount that you're paying, you're getting, or you're earning. If it's a matter of investment, if you're borrowing, it's a matter of lending. So it's the same amount of money that you're either earning or you're going to be charged over the time interval. That's the thing with simple interest. Well, compound interest it builds over the time that you're given. So that's the difference.
Okay, so if you look at the last two columns, especially the interest earned, you will see the way interest is calculated. On compound interest, you have a different, it is calculated on a different amount every year. Simple interest, interest is only calculated on the principal. Okay. Well, I'm just going to say the rest that I want to say. I wanted to show you a poster. In this example, the difference between the interest accumulated on the compound interest and simple interest does not look very significant. However, it would be different and very significant depending on some other factors like how frequently interest was accumulated. In this example, it was just every year, but it could be every month, every other month, 4 times a year. So it will be annually, semi-annually, monthly, daily. So it also depends on the amount that is put into the account. It also depends on how long the money stays there and whether the individual adds more money to the account. Okay, I just wanted to share a poster with you. Quickly, the power of compound interest. It just shows you. It says, hi, I'm Taylor. I started working when I was 16 to save money. By putting away $25 a week, look how much I will have. I will have earned. I'm trying to get it. Just now. No, but they said they're not saying it. Just 1 second. But it shows that it's sharing.
Yeah. Where's the
It says please move.
Oh, okay. So, I'm trying to think. Yes, you seen it now? Okay, so by saving $25 per week, 5.5% interest compounded monthly, she was able to accumulate $343,000 in 50 years. But she's actually depositing additional money. The 5.5% interest is not much more significant than we had, but she's actually depositing more money into the account every time. So that makes a difference in terms of how much money you're going to have during the period of time. Okay, so in my class, I have one more activity, but I'm going to give you the booklet for homework. Give me the booklet. Each student will get a booklet. I'm going to let you see what's in there. A booklet, it has space for your name, write definitions for principal, interest rates.
That's a second 20 minutes. That's a second, that's 40 minutes. It's a second 20 minutes. So you've exceeded you've doubled the time, that's 100%. I can't.
Okay, I understand that, but I was not teaching for the whole 20 minutes. I understand it was lengthy, but everything is not flowing. If I was teaching, it would probably be 30 minutes, maybe longer than 20 minutes, but it takes time to put things in and take things out and put things on the screen. And okay. They're gonna do it for homework.
Thank you.
Thank you.
Well done.
Yes.
Oh no, I can do that.
Sure, Miss Grace.
Okay. Hello, everyone.
All right, yeah, that's what is happening. All right. Okay, so Jeffra.
Yes.
What is happening is that Ms. Ferguson has to go shortly, so I'm going to allow her to go before you, all right? So
No problem.
only 2 more persons from St. Lucia, right?
3 more, myself and 2 more.
All right, so we're just, I need to allow her to go because she has to leave, all right?
Okay, no problem.
I go tomorrow. I can't remember when I go tomorrow. There's no money. It's not everybody because I think that we have to work it out. I would have stayed and do this today, right? So this was about we would have stayed and work this out today. But you don't plan for again, so we need to go today, right? So you factor in that you're going to leave early. I go early, but then they say the father they need to go now. No, but no, I didn't factor in. No, I factored that. Yeah, but we're turning back to the even saying something. I didn't hear it. You can go.
All right. Good afternoon, everyone. Hello.
Good afternoon.
Good afternoon. All right. Today, we're going to find the area of a right angle triangle. Last week, we calculated the area of a rectangle. So now we're going to break it down to a right angle triangle. So the first thing I'd like everyone to do, get a piece of paper, and I want you to create a grid. I want you to create a grid. Well, it's lead, you know. So, it's lead. It's going to be short. Yeah, I want everyone to create a grid. Yeah. I need everyone to create a grid. It doesn't matter how big the squares are or how small. The key thing is that it fills up the page. Now, the first person that finishes the grid, I'm going to give you a prize at the end of class. All right? Everything we did today, the fastest person, the one that finished fastest at the end of each activity, will get a prize. All right, so I want everyone to create a grid using the page. Just use a straight angle and create it. It doesn't matter, as I said, how big or how small the squares are. No. My grid, it is going to be called N, because my name begins with N. Your grid is going to be called whatever your name begins with. All right? Now I want you to, the amount of squares that is along the length, I want you to count them all. I have 1, 2, 3, 4, 5 squares, so it is going to be 5N. All right? And along the width, it is going to be the same. So you're going to count out the squares along the in your grid along the width, and you're going to call that. I have 5 again, so that is 5N. So along my grid, it is 5N squares by 5N.
Hello.
Yes.
Hi. Okay, well, what would be nice is if you could have the camera or share the screen or something, so having to or turn the projector towards the camera, towards the board.
We're not seeing the.
Just like Miss would have it towards the board, that's what you should. Right.
All right.
All right.
All right.
Lift it a little.
Other countries. So right here along the width, it is 1, 2, 3, 4, 5. So I have 5. It's 5N long. Along the length is 1, 2, 3, 4. So this is 4N long. Why I'm using N? Because that represents my name. So I want everyone. So the length of your grid, it is going to be whatever the number and your name. Just like how we did it last week, where you have centimeters. But this week we're creating your own grid. We're not using centimeter grids. All right. What I'd like you to do now is to calculate the total area of your grid with your previous knowledge from last week of calculating the area of a square, of a rectangle. So Dina, what's the area of your rectangle? Dina?
5D times 4S.
How you end up with the S?
It's supposed to be the same.
It's supposed to be the same as
initials.
Okay.
Times 4S.
4S. So what's the total area? 5D plus times 4S. So that is 20 DS. All right, great.
Just put that D.
Well, it's called the D squared.
D squared, right.
That's what you learned last week.
4D.
D, 20,
D squared, right.
All right. Now, what I'd like you to do, I'd like you, how do you think, given that we have the grids which makes up a rectangle, how would you form 2 triangles from this grid? Anyone?
Draw diagonal.
Draw diagonal from where to where? Which end to which end?
Could either draw it from the bottom here up to the top right corner.
All right.
Or from top left to bottom right,
whichever one. So now this is our diagonal. And we have our triangle. So let's assume this is triangle 1 and this is triangle 2. All right. Everyone is right. In the other countries, I don't hear anything from anybody else. I'm going to ask from another country. What have you observed creating the triangle from this rectangle? Anybody? What have you noticed regarding the size of the triangle in proportion to the area, in proportion to the rectangle? It's created a diagonal line from one end to the next. What have you noticed?
It's half of the rectangle.
It's half of the rectangle. Point. Point one. It's half the rectangle. We're representing it by 1/2. All right, great. Now, in trying to give them that, if you notice that the triangle one that we have over this side is half the size of the rectangle based on your observation. How do you, if it is half the size and the area of the rectangle is length times width?
Is a relationship between missing?
What relationship is that?
It cannot be any rectangle, you know, it's a bit of so almost you and it cannot be any other side of a rectangle. It has to be the rectangle with the same severe triangle. So there's a relationship between the triangle and the rectangle that was formed.
Mm-hmm.
You didn't mention.
Oh, I didn't. Oh,
you have to. That's very important.
Okay. All right. Thanks. All right. McCarthy, I just pointed out, and I didn't mention to everyone that the triangle is half the rectangle of being formed that was formed that we just created, or each individual in the class has created. So I'm going to make that point. It's not just any arbitrary rectangle, but the rectangle that was created itself. Now, given that the area of my rectangle, this is rectangle Nadira, with 4n and 5n, is 20. I have 20 right here, 20n squared. If our triangle is half the size of the rectangle, then how would you go about finding the area of the triangle? Anybody?
You look at the height of the triangle, the height of the triangle is similar. That's what I'm saying. The height of the triangle is similar to the rectangle that you have there. Same height. And look at the base of the rectangle in terms of the width of your base. Let's look at the base of the triangle, the width of your rectangle. So I'm saying there's a specific relation. The height of the triangle has to be the same height as the rectangle. That's the point I'm making. And the base has to be the same
base of your rectangle.
That's how we put the
I get you. All right. So we already start on one point and then we can get on to that. All right, guys. If the rectangle is half the size, if the triangle is half the size of the rectangle, how would you suggest we go about finding the area of the triangle?
Half of 20.
20n squared.
20, yeah.
All right. And the 20n squared represents the length times the width. Okay. In order to have let's go back in terms of calculating the height of the rectangle and the length and the width of the rectangle. One relationship we have to point out is that the height of the triangle is equal to the length. The height right here of the triangle is equal to the length of the rectangle. So in the future, Once we're calculating the area, we're deriving the area of the triangle from the area of the rectangle. We have to always bear in mind that the height of the triangle is equal to the length of the rectangle. Now the base of the triangle, which we had drawn the diagonal line from one point to the next, and this will form the base. This is equal to the width of the rectangle. So therefore, in this case, given that the length of the rectangle is equal, the height of the rectangle is equal to the length of the triangle, and the width of the rectangle is equal to the base of the triangle. Sorry, yeah.
That's H.
Length times height of X is equal, length is equal to height, and the width is equal to the base. So therefore, given that we have half 20n, which was previously height times the length times the width, then given that the length is equal to the height and the width is equal to the base, so the area of the triangle is equal to the half base times height. Everyone got that? Say yes. Now, using this grid, what I'm going to ask you guys to do, because I'm not fully satisfied that you fully understood the concept, I'm going to ask everyone to cut the grid out, just using the page, just using the grid that you created. Then now I'm going to ask you to find something which you think is a triangle, a right angle triangle specifically. I know everyone knows about the right angle triangle. That's this in class previous. You're going to use the grid that you've created, the grid, which is measured in Ds, and measure using finding a triangle within the class. Use this grid to measure the height of the triangle and the base of the triangle. Done? Found the triangle? Okay. Measure it. Half 5D times 40, what did we measure?
I counted the cells. So I counted from the bottom cell where we started the diagonal. I counted, and when I counted off the cells horizontally, I got 5 cells. It should be 5D, even I'm counting them in columns.
Yeah.
And for the height, I cut off, I made it at the cutoff point at the top, and that gave me 4 cells. That's actually 4 rows going on. Okay. So that would have given me 4D.
And then when you multiply that, you end up with?
So if 5D would be the base and 4D would be the height, then that would be 20D squared. 20D squared times a half, that's 10D squared.
Okay, very good. Okay. What have you learned regarding the relationship with a triangle and a rectangle in terms of calculating the area? Given that the triangle is half
the triangle is half the area of the rectangle.
Alright. And I will be giving you your homework. I'll be emailing it to everyone. So look out for the email. Alright, thank you.
All right, who's next?
Me.
Okay, go ahead.
1 minute. Can you see the PowerPoint?
Yes, we can.
Okay. Good evening, everyone.
Good evening.
For my class today, we're going to be looking at the main topic, statistics. However, we'll be looking at specifically the subtopic mean. After the class today, you should be able to define the term arithmetic mean, compute the mean of a set of numbers, examine word problems in which the mean of a set of whole numbers is computed. Now, we're going to use your previous knowledge on whole numbers, natural numbers, and all the terms, the concepts are listed there on the screen today for this class. And I have an activity for you to try out, an introductory activity. It's a magic triangle where you have to place numbers in the circles on the triangle so that each side adds up to a total of 11. You have 2 minutes to do this. I'm timing you. You place numbers in the circles on the triangle so that each side adds up to a total of 11. The numbers must be between, from 1 to 6, sorry. From 1 to 6. One minute and 30 seconds left. Remember, you can only use numbers from 1 to 6. One time.
Yeah, that's all. You put 2 each other in the 7 yes.
You have 30 seconds left. Anybody came up with the answer already before the time? No? You need more time?
Magic friend. 3 and 5 is it doesn't want to be
it has to be from 1 to 6, no? Not everything has.
Can you use the number 1?
Yes.
No.
Can you use
the number 1?
No.
Oh. Friends with 5. 5 and 6. I got it.
You got it. One person from the time is up now. One person from St. Lucia has it. Anybody from Muna? No?
Can I use negative numbers?
No, you cannot. It has to be from 1 to 6. Positive numbers only.
Sorry, because I didn't wasn't seeing it here. 1 to 6.
We have somebody here in St. Lucia with the answer. Sabina, you want to share?
Yeah, I'm just going to see what I have in the how do you call it? In the vertices, I have 6, 2, and 4. Between 6 and 2, I have 3. Between 6 and 4, I have 1, and between 2 and 4, 5. I don't know if that's right. No.
6, 3, 2. Yes, it's correct. I'm going to show you. Once you have these numbers in a line 4, 5, 2, 4, 1, 6, or 2, 3, 6, any combination of these numbers would add up to 11. Do you understand that?
Right. So all 7 numbers, they were supposed to be between 1 and 6, but not repeated.
That's what I said. Between from 1, not between, from 1 to 6.
Okay, so you could have used like 1.5.
All numbers only.
Okay, I'm hearing you now. I wasn't hearing you clearly. Sorry.
You are not hearing. But we got the solution from Sabina here, so we're moving on. Okay. The mean, is also called the arithmetic mean or average. Now, I'm going to give you a little scenario, and I want you to use these blocks. Can you see the screen and read the question?
Yes.
Okay. I want you to come up with a creative way using these blocks to share 21 sweets among Mary Jane's 3 children, Anya, Dina, and Ricardo. Now, you can see the children, right? Okay, now for the students in St. Lucia, I brought some tiny blocks, play blocks. So I'm going to give them, I'm going to give them that to use instead of these blocks. But you can use these blocks, okay? You have to find a creative way to share 21 seats among Mary Jane's 3 children. Yes. Go ahead. Find a creative way. A creative. It doesn't matter what, because remember it's seats. So
we need Mary, Ricardo, 1, 1. No, it's okay, right? Okay.
You only have 2 minutes.
Yeah, that's good food. So it's just 1 minute. So we can give them 2 yellow, 3 yellow, now we have 2 here.
It doesn't matter what color. Oh, they're sweet.
So they equally shade 3.
So Anya, you will come next. Jamaica, how are you doing? Are you getting a creative way to share the sweets?
Yes. Share the sweets.
So we'll have one person from St. Lucia share their way with us, their creative way, and one person from Jamaica. So Anya wants to share her way.
So what mommy did, she gave each one, like we had 3 groups and we just placed them one at a time in each group. And then at the end, when we shared all 21, we saw that each group had 7 sweets.
Very good. So each child got 7 sweets, but she shared them by giving each child 1 until she finished with the 21 sweets. Anybody from Jamaica wants to share?
It's pretty much the same thing.
You got the same thing?
No,
Okay.
We had 21 sweets, but we had some with different colors.
You had some different. No, it doesn't matter with the colors. They're sweet.
Strawberry and some were pineapple, some were.
that's That's okay. They're all sweets, and she just wants to share the sweets equally among her children.
Let's split those, you know?
Okay. Can we move along?
Yes, we can.
Okay. Now, since you are able to find a creative way to share the sweets, I want you now to, the number of sweets that each child got is called the average number of sweets per child that Mary Jane has. So I want you now to reflect, I want you to reflect on your report card at the primary school, where you usually saw an average at the end of your report card every term. What did that mean to you?
Whether you pass or fail.
What did it mean to you, Ricardo?
Yes, pay attention.
When you were at primary school last year, because you, well, not last year, you were grade 8. So when you were at primary school 2 years ago, you used to see on your report card the word average at the bottom, right?
Yes.
Or you used to see a figure at the bottom. What did it mean to you
Means
at that time?
because it actually tell me where my position in class.
Your position in class?
If I came first, second, or third, to see who is brighter than who.
It used to tell you it was brighter than who, but about you, about yourself, what did it tell you about you?
I'm doing some work.
Or not?
Or not.
I used to check the ones that they list. You know, when they list all the different tests that you do, the exams.
Yeah.
And you got a lot of 90s, and then you're saying, how comes your average is 70 something? When you look, one of the 5 tests you got 65 on, and you are just there crying because you're wondering why you got 65.
Okay, so to you, that's 1 grade would bring down your average.
Make me cry.
Okay, all right. Now, usually when you hear average, it's one number which represents a group, a data set, right? So that one number in your report book would have represent your potential as a student. So it tells you that you are capable of scoring. If it's your average was 65 at the end of your report card, it means that in every subject that you wrote at the time, you were able to score 65%.
Okay.
You understand that?
Yes.
Okay. So now I want you to take down this definition for me. And bear in mind the term that I wrote there. It's the central value. We'll need to go in depth into that term in a little while. Are you finished writing?
Yes.
Okay, really? Thank you. Okay, now from we're going back to Mary Jane's children and her sweets. From that little scenario, can you come up with a formula, a mathematical formula? Can you give me an idea of how you would have calculated the number of sweets that each child got?
The total number of sweets divided by the number of children.
The total number of sweets. So you're saying that you don't see it. Oh, you don't see? You cannot see the board, right? Okay.
The total number of sweets divided by the number of children.
Anya said it's the total number of sweets divided by the total number of children. Now, given that formula, can we write a general formula in mathematics, since we know that gave us the average number of sweets that each child got? Can we write a general formula that we can use for other questions to calculate average or mean? Anyone? Yes, can we? Anya?
Total number of, I guess, data divided by the sum of the data divided by the amount of data.
The sum of the data divided by the number, right? Of numbers added. Did you hear what Anya said?
Yes, we did.
Okay. So this is how we would get this formula. Mean is equal to the sum of all numbers divided by the number of numbers added, or the sum of all items divided by the number of items. We're moving along. I want you now to draw a number line for me. On your books, draw a number line. You can draw it from 0 to 12 or 0 to 11, but just draw a number line like the one I have there. What?
After such a exciting class.
Oh, well. Okay, now that you've drawn your number line, I want you to identify these three numbers. The number 3, highlight the number 3, the number 8, and the number 10. Now, using the formula that we created a while ago, I want you to calculate the average of these three numbers. Draw a line going straight through the average on your number line. Have you done that?
Yes, miss.
Okay. Okay. Now, from the number 3 on your number line, what is the difference between 3 and the average that you found? What was the average that you found in Jamaica?
7.
7. Very good. That's what we found in St. Lucia. What is the difference between the 3 and the 7?
4.
4. And in what direction are we moving? Away from the mean?
Away from the
to the right or to the left? So that is -4, right?
Yes.
That would represent -4 spaces. Now, look at the 8. Okay, I was just helping a student in St. Lucia. Okay, now to the right, what is the difference between the 7 and the 8? The mean 7 and 8?
1.
1. What direction? The right. Now, look at the difference between the 7 and the 10 now.
1, 2, 3. Yes, that's 3.
That's 3, and that's to the right, so it's +3, right? Is that correct?
Yes.
And if you add the +3 and the +1, what would you get?
+4.
+4. Now, do you realize the difference on the left-hand side and the sum of the differences on the right-hand side of the mean are equal? Hello? So that means the values are spread equally among the mean, right? Or around the mean.
Yes.
So the mean is a central value.
Good, very good.
Okay, we're moving along. I have a word problem there. I want you to tell me, give me a way that I can calculate the number of crabs that Peter sold on Wednesday. Yeah. Now, for this one, I'm going to have to do a little explaining orally because you cannot see the board where I am. It's okay. Remember a while ago we said that the mean is equal to the sum of all numbers divided by the number of numbers added. You remember that? Okay, so what information were we given in that question? We were given
The mean.
the mean. What else?
The total numbers that, well, no.
The number of.
Sold on each days.
The number of numbers.
He sold each days.
The number of crabs, sorry, he sold each day.
Yeah, the number of crabs.
So, okay. And how many? What else were we told indirectly there? Can you see anything that we were told? What happens to Monday, Tuesday, Wednesday, Thursday, and Friday? These are the number of days that he sold. What happened? What's the significance of Monday, Tuesday, Wednesday, Thursday, and Friday? These are the number of days he sold.
He sold 10 on Monday and Tuesday and 20.
But for how many days in the week was he selling crabs?
5. So we weren't given
5 days, right?
Yes.
So we're looking at 5 days, right?
Right.
So they gave us what he sold on Monday and Tuesday, and they also gave us what he sold on Thursday and Friday, but they want us to calculate the amount that he sold on Wednesday. So it means we'll have to rearrange our formula. Mean is equal to sum of all numbers over number of numbers added to find the sum of all numbers, right? Can anyone rearrange the formula so we can calculate the sum of all numbers?
Well, we can call Wednesday W. Given that we have all numbers for the other 4 days, we can put them and add them. So W plus all that's left there, and we know, of course, it's 5 days. So the number of days there, we have the number being 5. That's the denominator, right? And of course, the mean is 20. So we have W plus 75, that's adding the 10 plus 10 plus 25 plus 30. Divided by 5, all equals 20.
Right. So how do we solve to get W? We have to do the...
Excuse me?
We need to solve to find for W. You said 75 plus W, but we need to get W would be the number of crabs he sold on Wednesday, right?
Right.
So how do we solve to get W? If you look at the right-hand side, you will see that you are dividing by 5. If I have to get rid of 5 here, what do I have to do? Multiply the left-hand side by 5. So this becomes 20 by 5. And wouldn't that give you the sum of all the numbers added?
Yes. Yeah.
Very good. So what do I do? If I have the sum of all the numbers added and I have 4 of the numbers, I'm missing 1 number, what do I have to do to get the last one? Subtract.
Subtract the 75.
So I will get what?
25.
So on Wednesday, he sold 25 crabs. Like that. Can you see the board? Can you see the board?
We're seeing it, but it's not so clear, but it's okay, go on.
But you understood the explanation, right?
Yes.
Okay. Okay, now, oops. I want you to reflect on what you learned. I'm giving you 1 minute. You will write, you will use Freya's model and you will write, you will define the term, you will find characteristics, examples and non-examples.
I'm giving you another 3 minute stops.
Okay. Okay, your 1 minute is up for reflecting on what you just learned. I will collect this at the end of the class. I want you to take 2 minutes to solve this exercise. It's a very short exercise regarding what we just did.
Okay.
Are you done?
The exercise. Can you get the exercise, please?
You cannot see the screen?
Okay, I'm seeing it now.
The students in St. Lucia finished. They would like to share their answers with us.
Okay, thank you.
Yes, Sabina, the first one.
5.5.
Sabina said 5.5 is the answer. And whilst you were working, I passed around to look at what she did. She added the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And she divided it by 10. Okay, the second one, Tasha wants to try.
Okay, the average, the total was 654 over 12. So my average is 54.5.
Very good. Anybody got that in Jamaica? And the last one, the third one, Anya wants to try.
Just now, give me a second.
Anya wants 1 second to catch her breath. Yes, Anya.
X is 17.
X is 17. Is that correct?
Yes, yes.
Okay, thank you. And to conclude, I would like to ask anybody one thing that they learned today. Anything? Sabina.
The minutes calculated by adding the sum of, by adding all of the numbers and dividing by the number of numbers.
Did you hear that? Sabina said that the mean is calculated by adding the sum of all the numbers and dividing by the number of numbers. Now I'm leaving you with some homework. So next class, I want to see my homework, please. Thank you.
All right.
Miss McCarthy, it takes us a little time to share the screen. I think that's why we're having the problem with time.
All right, I'm back into my evaluation.
Okay.
Remove something.
All right, so who's going next?
Who's going next? Tasha. Yes, now Tasha. Let me take out everything.
You can leave that.
No, see the screen?
Okay, good. What else? Okay, good evening, colleagues. Good evening, class. Good evening, class. Good. I want to be interactive this evening. Can you hear me?
No, I missed that.
I said I want this evening's class to be interactive.
Okay.
Okay, good. Now I have some color posted notes in my hand. Can you see them?
Yes, we can.
Good. I'm going to stick them on the board. I want you to observe for me, please. Can you see?
Yes, we can.
Good. What color is the first one?
First one, counting from.
Bottom or top?
What color is it?
Which direction you want us to count from?
No, I'm just telling you what color. Oh, the top, sorry. What color is the first square?
Red.
Red, excellent. What color is the second square?
Yellow.
Wonderful. What color is the third square?
Green.
Green, as you can see. And the last square?
Blue.
Blue, excellent. Now, I want everybody to pick a color of choice.
Red.
Dominica, St. Lucia, Jamaica. So let's look here. St. Lucia, how many reds we have? Pick a color.
Red.
One red from St. Lucia. How many yellow from St. Lucia? No yellows. How many green from St. Lucia?
One green.
Two greens.
Two greens.
How many blue from St. Lucia?
One.
One blue. Anya. Jamaica. Have you picked your color?
Red.
Red. How many red from Jamaica? Count for me, please. I can't see.
One.
How many?
One.
One red from Jamaica. How many yellows from Jamaica?
One.
One yellow. One.
One?
Yes.
Good. How many greens from Jamaica?
One.
One. What about blue?
One.
One.
Okay, is Diane around? Oh, so it's just St. Lucia and Jamaica here, right? Okay. Now, as you can see, we have some information written. Can you see the information written on the board?
Yes.
I have the names of the colors and I also have the total picks that were selected. Now let me ask you a question. With the information I wrote on the board, how can I present this data? What are possible ways I can use this data and present it? In the form of what? Give me some ways. Solution? I heard a word, graph. I'm going to write it down. Graphs. Jamaica?
Tables.
Table,
Pie chart.
Pie chart. What else?
Number lines.
Bar charts.
Bar charts, number lines. What else? How can we present our information? Okay. Line graphs. Very well said. This evening, I want to look at a particular type of graph. And I'm going to write the name on the board. Can you see that? What's written there?
Bar graph. Bar graph.
Ah, graph. Have you seen that word before? Yes, you have. So tell me, what do you think a bar graph is? We have done it already
A graph with
in previous classes, so you should know what a bar graph is. So let me hear a definition for a bar graph. Jamaica?
So it's a graph.
Yes. Tell me.
It's a bar. Yeah, it has bars. So that's what it. And generally, like each bar represents a number. So it's right. So on the bottom, you would have different categories, and then you would have numbers on the side. Generally,
like heights. Like you have the bars and heights representing the number.
Okay, you are quite correct. So we all know what a bar graph is and the definition. Here, I'm just going to refresh your memory of it. Can you see the chart?
Yes.
Good. I have a chart here which says bar graph, and it says a diagram that shows data using bars. Are you with me?
Yes. Yes.
Wonderful. And as we know, there are different elements to constructing a graph. I'm just refreshing your memories. We said bars must be of equal size. Wonderful. An axis must be labeled correctly. Excellent. And data must be shown or written also correctly. Again, I am just refreshing your memories. Here, sample of a bar graph. We have the x-axis, and we said it is also known as the number line, right? Right?
Right.
And we have the x-axis, which is the data line. This is where you put your information. And here I have a small sample of what a bar graph is. I have colors, which is red. The first bar is red, green, and blue. Not forgetting our label. It says the title of our bar graph. Title, favorite t-shirt colors. And again, we have our number line, red. How many persons like red? 25, excellent. How many persons like green? 20. How many persons like blue? 30, wonderful. So I am just refreshing your memory. So this evening, I want you to assist me in constructing a bar graph with the data that we collected, with the various colors that were picked by us here this evening. So, what do we start with? Refresh my memory.
Drawing the graph, x-axis and
the y-axis and the x-axis. So, how many colors we have here?
4.
4. So, red, yellow. So I'm going to place the colors here. The first color was
Red.
Can you see?
Yes.
Red. The second color was yellow. The third was green, and the last was blue. Good. So, what? Okay. First of all, we need to what? Assist me. Label the axis. Again, we can use any numbers, 1s, 2s, 5, pertaining to the data that we want to show. So what will be better? 1s, 2s?
1.
Huh?
1.
Very well. You said 1. So we're going to go. All right. How many persons? 0. All right. How many persons like red again?
2.
2. Very well. So again, we must ensure that the bars are equal. How many persons like yellow?
1.
Jamaica?
1.
Excellent. How many persons like green?
3.
3. Very good, St. Lucia. And how many persons like blue?
2.
2. So, did we present our data collected?
Yes, we did.
Good. Now that we have presented our data into what kind of chart again? Let me hear you. A bar graph. We want to learn how to answer questions and also to solve problems based on data presented in a bar graph. Wonderful, in a bar graph. So, let me hear St. Lucia. Let us answer some oral questions quickly. Tell me, what can you tell me about the bar graph? St. Lucia. Let me hear you, Anya. Just tell me.
The bottom put together.
Okay.
Green has the tallest bar.
All right.
Yellow has the shortest.
Wonderful, excellent. Jamaica, tell me. Tell me, what can you tell me about the bar graph? Jamaica?
Same amount.
They are what?
Red and blue have the same number. Did anybody say that?
Uh-huh. Okay, I'm going to ask another question. What color was picked by most students here this evening?
Green.
Green, wonderful. And how many picks did we have?
3.
Wonderful. I'm going to ask another question. What color was picked by the least amount of students?
Yellow.
Yellow. And how many did yellow have?
1.
1. Beautiful. Well done. So we have shown that we can answer questions orally, and if we were to write it, we can answer questions based on the data presented using let me hear you. Bar graph. Yes, I want to hear you. I want to be interactive this evening. Now, we come into another stage here. Now we can answer oral and written questions if I were to give you a written question, but you already know this. We want to solve questions based on a bar graph. But I want you to keep in mind that every time you solve a question, you need to pay attention to keywords in a question that pertains to data presented in a bar graph. Are you with me?
Yes.
Are you with me?
Yes.
What are some of the common terms you will find in a question or a question to solve? Find.
How many?
Determine how many. Let me hear you. Jamaica.
Show the results.
Show the results or total.
Show that.
More. Well done. Now, another thing. Certain terms will assist you in knowing how to solve that particular problem. Are you with me? I'm giving you some tips this evening. Are you hearing me?
Yes.
Yes. Certain terms will tell you what operation to use and how to solve this problem. And I'm going to give you one. I'm going to remove my chart because of space. For example, find the total number of picks for the color red and green. What was the important key term I used there? Find the
Total number.
Total number of picks for the colors red and green. Can you see that?
Yes, we can.
What other keywords here? Tell me.
Total.
Another one. Fine. Good. So tell me, with these two terms, what sign you feel we might be using here? Tell me.
Please.
What's that?
Repeat what you said, please.
I said What operation do you think that we will be using due to the terms that are used in the excellent? So, like I was telling you, different terms will give us a notification as to what operation to use to solve the
problem.
Excellent. So here we go. Assist me now. How many picks we had for? Right again? 2. 2. What operation are we using?
Addition, sorry.
Excellent. And how many picks for green?
3.
3. Excellent. So what is our total?
5.
5. Wonderful. So, like I told you, different terms will assist us into knowing what operation to use when working. Okay? Good. I want everybody to solve this problem for me. Calculate the total picks for all 4 colors. Calculate the total picks for all 4 colors. What is the keywords in here? Calculate and total. I'm going to repeat it again. Calculate the total costs. Sorry, calculate the total picks for all. Did you hear me?
Yes, we did.
You have 1 minute to do so. What's that? Do you have it?
Yes.
What's the answer?
Yes.
Excellent. 8. Wonderful. Good. To conclude my lesson, each group, so we have St. Lucia and Jamaica now, I want you to look at the bar graph and I want you to create your own problem and then you will share with us, the class, how you solve that problem. You are going to create a problem based on the data presented in that bar graph and then you are going to share with your classmates how you find a solution. Remember, I want you to use the key terms. Are you with me?
Yes, miss.
The key terms. So we use. You have 1 minute to do so. Remember, you are going to create your own problem using the data shown on the graph, and you are going to share your solution with the class. You have 30 seconds left.
What fraction of C of choose red? What fraction to choose? You can tell that you see. Yes. The guy really did so.
Why is it that?
What's the English?
Okay, are you done?
Yes.
Solution, let me hear your problem and you are going to share that solution with your classmates. Let me hear you. Anya is on the floor now.
What? What fraction of students chose red? And there will be 2 out of the total, which is 8, so that's 1/4.
Okay, very well done. Wonderful. Let me hear a student from Jamaica. Do you have a problem ready to share with the class?
Okay, yes.
Let me hear your problem and your solution.
All right. The difference between the one that was chosen, the one that was chosen by most persons, and the one that was chosen by the least persons. So the difference. So the difference between the
number of picks for the
green bar and the number of picks for the yellow bar, and that's 3 minus 1, which is 2.
Okay, excellent, phenomenal, well done. So in closing, I want to tell you that whatever data that we collect, there is a way to present it. And we looked at one way, and what is the way? It's just one of the ways. Bar graphs, we can use a bar graph to answer questions orally and writtenly, and also we can solve problems based on the data presented on the bar graph. Now, I want one person from St. Lucia to tell me what you have learned about the lesson, and also one person from Jamaica. Tell me what you have learned in this evening's class on bar graphs.
The heights of the chart.
Let me hear St. Lucia, let me hear you speak loudly.
The taller the chart, the more what data it has. Yeah. Then what the greater the data it represents, the taller the bar.
Okay, Alex said the taller the bar, the higher is the amount, the data represented. Is that true?
Yes.
Is that true?
Yes.
So the higher the bar, she said, the more data is shown. So here the highest bar was green. It was the tallest one. So we had a total 4. Three, sorry. Jamaica, what did you learn in this evening's class about bar graph?
It is important to label your axes.
Yes.
Data.
Very well. Because let me tell you, if we do not label our axes, someone looking at this graph right there will be lost, totally lost, right? Totally lost. So however, you need to ensure you label correctly both your y-axis and your x-axis. And more importantly, always ensure that you know your title. You always have a title. Because if you do not have a title, someone who's reading this chat, the data presented will not know what you are talking about. Am I right or am I wrong?
Right.
Am I right or am I wrong?
Right.
Wonderful. All right. So you are correct in the Jamaica. You must ensure that you label your axis and your data is presented correctly. Any questions, boys and girls? Okay. Well, if you have any questions or any queries or any feedback, you can always WhatsApp me. Thank you very much. I hope that you learned a lot in today's class. I will now hand over to Zana.
What's your now? What this is? The PowerPoint. EDMC. Everything. Just copy everything onto the desktop. Yeah. But I want the PowerPoint. Only when I want it. You don't have that. Just do it.
We're seeing you, Zana.
Zana?
Hey, Zana.
You're so pretty. What happened?
Can I clarify one thing? It is 7:45, and I understand that we have had a long day. Please permit me to present that presentation. Do not, I know some of you have the habit of teachers here, you're packing up your laptops, you're ready to go. Give me like 15 minutes, please, 15-20 minutes. So please pay attention, and we will be out of here by 8 o'clock, hopefully.
Which one? Yeah. The PowerPoint? Yeah.
Okay. Okay. Okay, I'm getting ready. I'm ready to begin. All right. Good evening, everybody.
Good evening.
Okay, Zana Octave, I'm presenting. Algebra is my main topic. However, I'm looking at algebraic expressions, more specifically simplifying algebraic expressions. Okay, so what we'll be looking at today, what we want to achieve at the end of the lesson is simplifying, distinguishing between like terms and unlike terms. We'll be using an activity for that, and recognizing that we can only add and subtract like terms but not unlike terms, as well as simplifying algebraic expressions, the same thing, and completing a pyramid. So this is our introduction. I want you to pay attention carefully. This is what it reads. Everybody with me so far?
Yes.
All right. As I was going to St. Ives, I met a man with 7 wives. All right? As a man with his 7 wives, each of the wives had 7 sacks. In each sack, there were 7 cats. And in each of the 7 cats, we had 7 kids. So tell me, you kids, cats, sacks, wives, how many were going to St. Ives? You have about maybe half a second to do that.
29.
How many? How many?
29.
25?
How many what?
How many were going to St. Ives?
I'm just trying to right. 49 times 7 times 7.
Okay, your time is up, but listen here. If you pay attention to my introduction, this is what I was saying. I went to St. Ives, wasn't I? I met a man with his 7 wives. He had sacks, cats, kids. I was the one going to St. Ives, so only one person went to St. Ives. That's the answer. There's no calculation involved. Okay? All right.
As you were going,
how many were going to St. Ives? I met a man with his 7, but nobody knows that he was going to St. Ives. I was going there. So do you have any questions? Nonetheless, that was just an icebreaker to see if hopefully, you would have just calmed down. And most of you, I know you really want to go already, but then, just to get us into the topic. What we'll be looking at is algebraic expressions, like I said. I want you to take out your algebra task because that is our manipulatives for understanding algebraic expressions for today. So what I want you to do is to take out your algebra task, and we will be expressing the following statements. X plus 4, 2x plus 3, and negative 4x minus 2. So with the algebra task, you know that we used it before, that the red will represent negative. We have the square for x squared, the negative x squared will be in red for the squares. And you have the rectangles for x and the single blocks for 1. Okay? So you will put together, using your algebraic task, you want to represent each of the following algebraic expressions. X plus 4, 2x plus 3, and negative 4x minus 2. So I'm going to ask somebody from Jamaica to quickly show me what would you use to express the first two, and we'll have one person from St. Lucia. X plus 4, what did you use? Anybody?
Parallel squares.
4 units and
4 units and one X.
4 units and white X, a big white X.
You're going to use a big white X, which is the rectangle.
Right, a rectangle.
4 little white squares.
And four small units.
And 4 small single. Excellent, that's correct. 2x plus 3.
That's still us. Still Jamaica?
Yes, still Jamaica. 2x plus 3. You would use?
2 of the 2 X's, 2 X rectangles, and 3 of the unit squares. 3
of the unit squares. Excellent. St. Lucia, what would you use for negative 4x minus 2?
4 red X's and 2 red ones.
Excellent. So what did you observe? Did you go about adding x plus 4 and say that the answer is 5x, 2x plus 3 and saying that your answer is 5x, or negative 4x minus 2? What did you do? You kept it the same way, right? So you observe that x and 4. What do you observe about x and 4? Are they the same?
No, they're not.
X and 4 are not the same.
Yeah,
so therefore we can say that they are unlike terms. So let's look at the first activity. Let us simplify 2x plus 4 plus x plus 2 using our algebraic task. The first two. And then we'll look at the discussion to explain the answers. So we'll start with St. Lucia first and then we'll go to Jamaica. How would you represent 2x plus 4 plus x plus 2 using your algebraic task?
2 white X's. Plus another white X.
Right.
4 ones and another 4 white ones. Both of all them and 2 white ones. Sorry.
Okay, so what did you do basically? What would you tell me your answer is in simplifying it?
So in all, I have 3 white X's and 6 ones. So that is 3x plus 6.
Excellent. Jamaica.
We're doing number 2.
Number 2.
So we have 3 red X squares. We have 4 white X's. Yeah, 4 of the long. Yeah.
Right.
And 1 white square.
Right.
That's X square and 3 units. White.
Okay.
White units.
So what do you observe having in common? Do you observe any 0 pairs?
Oh, we're getting to that.
Yes.
So your 0 pairs would be what?
The X squared with 1 of the
Your x squares, right? So what would be your final answer?
2x squared.
2 red X squares.
Plus 3x.
2 red x squares plus 4x.
That's 2 red X squares plus 4x plus 3 plus 3 units.
So this is what we just did. We learned to simplify, bring together. That is what the term simplify means, even if we did not know the definition yet, but we understood that we can bring terms together that are like, as opposed to terms that are unlike. So what we did, we brought together the things that were common, and we left the things that were uncommon. So basically what we learned is that you can only add and subtract like terms and not unlike terms. So this is the discussion, this is the solution. So what can we say about like terms? We'll fill in the blanks. Terms with what? Terms with the same variables. And what does the same variable mean based on what we did? Same means variables with the
Same letters.
Same letters and
Same power.
And same powers. Excellent. Did you get that, Jamaica?
Yes.
So like terms basically are terms with the same variables, and same means variables with the same powers and same letters. So what can we say about algebraic expressions? Let's fill in the blanks. We simplify algebraic expressions by combining like terms. Excellent. So to combine like terms means you have to add or subtract. To do this, you have to work with the, what are we working with? When we add like terms, what did we observe that we are working with?
The coefficients?
Right, the coefficients of the like terms. So based on what we did, let's take a look at it. In the classroom where we are, let's say T represent girls. So there are 5 girls in the classroom. So I would be 1 girl, Anya, Tasha, Geffa, and Sabina. So there are 5 T's. How do we express that? So we say the 5 girls, do we express 5 girls as being Zana, Anya, Tasha, Geffa, and Sabina? Or we simply say there are 5 girls. So that's what it basically means. So we can only add things that are common. What is common among us is that we all are girls. So T plus T plus T would give you 5T. Now, that was more or less the discussion we were supposed to have in the PowerPoint, but we have completed it already, so we are going to continue right into our activity. Representing you the algebra task. So what I will do, I will share a pyramid that you will complete, and that will probably take you about 3 or 4 minutes to do, and then we will share the answers, and then that will be the end of our presentation. So what your instructions are, you're going to reach the peak of the pyramid by simplifying the algebraic expressions. So the first one was done for you. You're going to add the bricks until you get to the top. So 9A plus 13C, we know the answer will not be 19AC, but we know that they are different, so it will be 9A plus 13C. Can you see the activity on the board, on the screen?
Yes, we can.
Okay, so that's what you're going to complete. It might take you about 2 to 3 minutes to get to the top. We have about 2 minutes left. Anybody got to the pickers yet? Still working? Anybody, anybody's completed? Anybody got to the peak? Okay. For the interest of time, I observe that it may take you a little longer. So I will provide you with the answer. I'll post it up on the screen for you to see. So by the time you got to the peak, you should have gotten your answer to be 26A minus 165B plus 78C plus 108AB. That is your answer. So, okay, you did not get half of the answer. You didn't get anything. For your reflection, back to the slides. All right, for your reflection, what I would like you to do, you could write your 2-line summary on WhatsApp so I could have my evaluation as to what you learned in today's lesson. So to conclude, we learned how to add and subtract unlike terms, and knowing that we can only add and subtract unlike terms and not that of like add and subtract like terms and not unlike terms. The technician is here already. It's 8 o'clock, so we have to leave. So I obviously had to rush.
Let me quickly conclude. Good job. I must confess that, can you all hear me?
Yes.
I'm pleasantly surprised by how creative and the quality of the lessons so far. You guys have done a very good job. Give yourself some claps. I have some very high scores here. I don't know if I'm allowed to give these scores, but let's see how you perform on the other assignments. But very good. I must commend you guys. Clap yourselves. Very good.
Can you send it to us through email?
If I can send the scores, all right, so tell you what I'll do. So I'll wait until everybody is done teaching the course that's sending those scores because I'm very interested.
Okay, no problem.
All the scores at the end when everybody is finished teaching. Because then it's going to get very distracting. Everybody try to discuss their score and blah, blah, blah. So we'll send them out at the end. So by Friday, okay, we'll put it. by over the weekend, sometime you'll get it. You'll get it. If you don't get it, somebody send me a WhatsApp to quote me, and I'll send out to you. And you can by Sunday at least, you can WhatsApp me personally and tell me the grade, okay? Okay?
Yes, thank you.
So it's a lesson plan and micro teaching.
No,
teaching.
Sana, did you get my email?
I didn't get that.
Did you get that email to you and Jeffro?
Yes, we got it. Thanks.
I think you guys are going to be together tomorrow. You're all going to be at the same place tomorrow?
No, we'll be at our separate locations. We only got here for the day.
Is it possible that you could share it with your colleagues, please?
I didn't get that.
Can you share the documents with your colleagues for me?
Yes, we will.
I will need your input.
All right. Bye-bye.
Bye, Jeffro. Where's Curly?
He's not there today.
All right. I'm not sure. Let's calculate some. Okay, guys. Tomorrow. So tomorrow, okay. Tomorrow you'll be here for 2, right? If you didn't teach it, you need to come for 2. You didn't teach it, you have to teach it. Hallelujah. It's